Playing and the guy's got a
Just loading really, really slow.
adjusted. No, it's up. My inbox. This is the new Google inbox.
There you go. It came in.
It worked out.
It is. First time we get it.
What's the name of that?
In an hour. It's trying for 3 hours.
Sounds like
I could have been. I was in that game. Oh, yeah.
Still going. Let's see what I've got.
Sometimes.
Thank you very much.
Good. Thank you. Thanks.
No copy that we're going to do.
yeah, no.
You can go walking.
Thank you. Just
That's not.
Yeah, there's a guy Where's that guy?
Huge lag.
Oh, there's your turn.
So it looks like it's working then.
So it is.
8-second delay. So you can.
Whoa, it's a smooth lag.
I'm in the
Oh, yeah.
I don't remember where I put it.
Oh yeah, here we go. Yeah.
Oh, there you go. So about 15 seconds.
But like it's
It actually looked okay.
that's impressive.
That's great.
I'm impressed.
It's the video on link.
Especially if you text me or email me that link. I'll
Going up is getting
Nzito, Zito, at choose YouTube,
They gotta start competing with like Twitch and stuff. What is? No, YouTube was.
What, Amazon, not Twitter?
Yeah.
you and 6 others are going to the 6.
Oh, I need to unregister.
Oh, me and 5 others. Yeah, so you haven't seen the new inbox?
No. As much as I love
It's mainly for
going to children's plays.
it's, as you can see, it's mobile first. But they do a lot of groups and manage it. And come in here and say, yeah, okay, I know what all those are. I don't care. I can check them done. I can have them pop back up later, so I can snooze until a little late and then pop back in. Stuff like that. And then, here's your inbox. You use Gmail?
Yeah. Is it an option in there? Or
No.
something?
What's your email? You gotta have an invite.
Mike at ns12.com.
There you go.
We'll check it out.
What's up for next, Joe?
Did I give you one?
Next.
You want one? Everyone agrees.
I know
I like to try and get some pictures during the presentation.
The only thing I don't like about it is they haven't brought in calendar. So I gotta switch over to, which is annoying even in that. You have to, but if you log in your local site,
So they're all back out, because that's where it's at. And then they're expanding to.
it's like all this. Huh?
Well, what that was.
Yeah, so far not too bad.
Alright, well, so, I don't want to be fast about this ticket thing, but I'm just making sure. Does everybody have a raffle ticket? Alright.
Yeah, we got 2 JetBrains licenses. We got the
Pluralsight.
Pluralsight. We got $50 gift card. Friar. No, there's no Friar.
Should we enter early and often?
Right, yeah. Yeah, different name and email address every time.
Mention something?
Yeah, yeah.
My name is Mark Quigley. I own a company by the name of Designer Software, and we're looking for a couple of interns that would help put together some localization on our Java platform. It's a SaaS platform. It does business planning and financial modeling. So if anybody knows of any interns that might want to help work in the project, please come see me. Meet me after the meeting tonight. Thank you.
Joel's gonna start announcing stuff right at 6, and then Texas will say something for a minute. Okay. And then I'll start up.
Cool. But she's like, she jokes to come friends.
Do you have any pizza or anything?
No, I've had no thanks.
Yeah, it's good too.
It's not easy.
Yeah. I like stuff running on the cheese like that, but it was a little confusing when we were trying to figure out what pizza was the White House.
I couldn't figure that out either. All I managed to
Yeah, it turns out it's good to figure it out. There's a little peep on the front of this.
Get fish license. Where are the swim? Okay.
Should have been like a huge thing on the top.
I know it's hard to complex file. I'm like, yeah, some of that stuff. Just like, what? But then there's others.
Yeah, I know the order you want it down. This is Rajah. He was going to help us with our project, and then he didn't.
It's an old story.
right. Well, it wasn't his fault. That happens a lot, really, full block, you know.
So that's what they're answering the test.
Yeah, I mean, like. Well, mention we're streaming.
The fact that
Oh wait, maybe.
Yep.
There it is.
All right, well, thank you all for coming out tonight. I mean, today was a beautiful day as well, and I'm sure if this wasn't going on tonight, I'd be out there playing tennis. And so thank you all for coming out, and we have, a really exciting presentation by Uncle Bob. And so up front, so some of our sponsors, so Rev3 and Tech Systems. Tech Systems has been really awesome supporting the SDC, and so food and drink tonight is provided by Tech Systems, and so for, they're going to say some things, but I know Mike and I and a couple other people from SDC, we've worked with Tech Systems.
Yeah, I've actually been placed by Tech Systems twice, and they've been a great company to work with.
So definitely reach out to them if you're looking for something, or even if you just want to kind of get some kind of career enhancement opinions or something, whatever. So it's and also Rev3, and they're going to talk as well. So this is Rev3's location. So basically, if you have some kind of idea for a business, something like that, you can become a member of Rev3, and they'll help you with that and help you make it a reality. But Nick's going to talk about that anyways, so I won't talk too much about that. But let's see. So and obviously tonight we have Uncle Bob coming, and he's going to talk about he's going to do a presentation today. So other than that, I'll just let so I'll remind you again, if you haven't done it already, grab the damn raffle ticket, and so we're gonna wrap some stuff off. And other than that, I'll let Tech Systems start, and after that will be Rev3, and then after that will be Uncle Bob. So.
Thank you. So we appreciate you guys having us out today. We love to come out to these things, really network with you guys, make sure that you guys know about Tech Systems if you have or haven't worked with us, give you a little bit of exposure to that as well. I'm being interrupted over here. So we'll just get started kind of with who we are, what we do overall. So just to give you some idea, Tech Systems, we're one of the largest IT service and staffing companies in the nation. Overall, we work with about 25,000 consultants nationwide, partner with over 1,500 companies, specifically within the Chicagoland area. We partner with over 400 companies. We have 4 offices throughout the Chicagoland area, 1 in Downers Grove, 1 in Schaumburg, which Abby represents, and then 2 downtown. They're split up between applications and network. So want to kind of give you guys an idea of who we are. Don't want to take up too much of your time though, so we'll just get really into it. Had some technical difficulties, so bear with me. So Tech Systems, we want to kind of go over, what happens when you're engaging with us, not looking at kind of the benefits of partnering with Tech Systems. So when working with Tech Systems, so like I said, we're one of the largest IT service and staffing companies in the nation. We like to make sure that we're keeping you up to date with current trends within the market. Tech Systems, we become much more specialized within recruiters such as ourselves and even account managers. So rather than being generalists, we like to be specialists. So whether you're a Microsoft technical professional or a Java or a PM, BA, we want to make sure that we're specialized within you and making sure that you're aware of those market trends. So that kind of bleeds into the specialized career consultants. We want to make sure that you're having that experience, not having someone who kind of, like I said, is a generalist, but really narrowing in, hey, this is what you do, I understand it, you know, as technical as you can be within that, and also make sure that, hey, we know what you're looking for, we know what hiring manager is looking for, so we can convey that to you as well. You know, really our clientele, client intel and size, we don't just work within the financial industry or the healthcare. We're really broad across from that. We have really, you know, skill set alignment within them as well. So whether you're looking to be in finance, healthcare, energy, retail, manufacturing, the list goes on. We want to make sure that we're customizing that as well. Also, you know, we make sure that we're meeting with you guys, not just, you know, throwing your resume over there and crossing our fingers. We want to understand your skills, goals, and interests, not say, hey, you know, you're a C# developer, I'm going to place you in 5 things and, you know, let's see what happens, but really understanding what you do and what's going to be the best fit that you excel in or are happy in. And going into that, really, you know, making efficient searches for what you're looking for, and then resume coaching, you know, this is what they see, this is what works, and, you know, it's going to be the best option for you. So Abby's going to kind of go into what happens when you're not necessarily looking for your next role.
Yeah, so like Stephanie said, I'm Abby. I work out of our Schaumburg, Illinois office. So within the IT space, we know that unemployment's about 1.5% at this point. So chances are you may not be looking for a new opportunity, but we still like to kind of build a connection with you, you know, network a little bit, build those relationships. We can help just kind of guide you in your career. So if you think, you know, I want to move into more of a leadership role, we can tell you what we've seen technical professionals like yourself have success in, and kind of understand the market, know what's out there, and kind of let you know that as well, even if you just want to grow within the company you're already in. And like Stephanie said, we also know the market knowledge and technology trends. That's what we do every day. We're always in this space, so we can just keep you kind of focused and know what's out there. And maybe down the line you might be looking, and you'll know exactly what we have kind of going on in the market continuously. And we just want to make sure you're advancing in your career, so we'll understand exactly what you're looking for, exactly kind of the work that you've been doing, and like I've said, what you want to be doing in that ahead. And you never know what could happen. If you're a consultant, projects may end, budgets may get cut. If you're full-time, there may be some layoffs. So we'll be there for you, and just continuously build a relationship. That's kind of our goal.
So again, my name is Sherelle. I sit in the downtown office, and basically I'll talk to you a little bit about the benefits of working with Tech Systems. I know they kind of went over a lot of the benefits, but we do have a virtual support community. So once you become an employee of Tech Systems, you'll have access to hundreds of training. So if you do want to kind of venture out, look a little bit more into maybe you want to get your PMP, or maybe you want to learn a little bit more about mobile development, or whatever kind of interests you on your project, you can go onto the virtual support community website and be able to kind of play around with some of the different assessments we have and different kind of different trainings that we have to help support you within that, and then maybe that can be something you're doing your next contract. And then in terms of a retention program, we do focus heavily on once we, once we've supported you in a project before, or if you're currently working for us right now and you're coming off contract, we want to make sure that about 30 days before your contract is ending, that we're doing everything we can to start marketing you and getting your next opportunity. So unless you have a vacation coming up, if you end on a Friday, we want to make sure you're starting on a new project on a Monday, so you don't have any gaps of employment. So we do have a separate program outside of your recruiter, which would be one of us or anyone else within Tech Systems. We have another recruiter called the retention recruiter that would reach out to you and also help market you as well. So the biggest thing is we just want to make sure we have as many people helping marketing you and making sure we're not missing any opportunities, and we're being proactive in your search. Another benefit would be our diverse customer base. Kind of like Stephanie said, the biggest thing is we do not stop at industry. We keep going in terms of embarking on new industries that we kind of find within the Chicagoland area. We support healthcare, manufacturing, software, IT. So we have numerous different industries that we do support. So anything that you might be interested in, we can definitely be able to consolidate and show you kind of what who our clients are that are within that industry. And then in terms of specialization, Tech Systems really prides ourselves on making sure that we are specialists in what we recruit on. So we do specifically just recruit within the Microsoft space 24/7. We don't branch out into any other skill sets, and that's just across the board within Tech Systems. So with Stephanie, Abby, and I, we support Microsoft services, so anything within .NET and SQL as well as SharePoint, that's what we recruit on. And that's a big benefit with understanding the marketplace, the trends, and kind of really understanding what you want to do and being able to be a voice for you in the market. And then in terms of national presence, within the Microsoft Support Service team, we have over 45 recruiters that sit on this team within the United States and parts of Canada. So a lot of what we do is really impact the client on basically what you guys are looking and interested in, and being that voice and saying, hey, you know, this is the market and this is what they're looking for and this is what they're interested in doing, and being able to relay kind of the big initiatives to you guys. So that's really kind of what our team is about, is just being that point of contact for you to have enough information that you can to move forward on opportunities, or at least be knowledgeable about what your options are. That's pretty much
So,
it.
yeah, we appreciate you guys having us tonight, you know, listening to Tech Systems, what we do. I know we failed to mention that we don't only just do consulting, we also focus within the contract hire and full-time space. And then we have a huge presence nationally with those 90 different offices. So feel free, we're gonna stay here, come up to us, you know, just have a point of contact or anything. So again, we appreciate you having us, and hope you have a good night. Thanks.
Thank you. And so Uncle Bob, everybody's waiting for, you know, the presentation. So
Ready for me? Okay. All right. And turn this thing off here.
Joel, while you stand up, okay, say something.
Did I just say something?
Yeah, just really quick, I won't take time to wait for you. On behalf of Rev3, welcome everyone out tonight. So I work for DuPage County and I run Rev3. We're a business incubator and co-working space. I was talking to a few people as you were walking in, and there's a huge void currently in the suburban landscape. So our goal, simply put, is to foster entrepreneurship and small business creation within DuPage County and the suburbs specifically. So we have about 20 member companies that we host here, about 70% in the traditional IT software, you know, startup realms, a lot of software applications, a lot of web and mobile type applications, and then our niche is kind of physical manufacturing. So hopefully towards the end of summer we'll have a full-scale lab, 3D printing, and kind of mix, you know, the niche again of kind of married together the components of tech and manufacturing. My contact info and number is on the orange flyers, and my cards are back there. Again, we house freelancers, small companies, you know, pitch rooms, but then we also give company services. So we have connections to angel investors, attorneys, CPAs, and again, our goal is to see successful companies launch here and then kind of branch out off on their own. So we're really happy to always host awesome content like this with SDC, and very excited to hear Uncle Bob speak tonight. So if you have any questions, grab me after. Thank you very much.
now that you've all been waiting for it.
Okay. How old is this industry? Software. How old is it? And let's define it. Electronic digital computers. Electronic stored program digital computers that you would program by loading instructions into computer memory. How old is that?
And you going to count tubes and all?
Yes, of course, tubes. Absolutely.
60 years? 70 years?
70 is probably a good number. The very first stored program electronic computer was built in 1946. Prior to that, there had been some electronic calculators and electronic computing machines, but none of them would have qualified as a computer as you and I would know it. None of them would have been programmed the way you and I would program them. 1946, one computer. Its name was ACE, Automated or automatic computing engine. It was designed in part by Alan Turing, and he was one of the few programmers on this machine. Most of the code that he wrote never executed. He wrote quite a bit of code, but never managed to execute it because the machine was very unreliable and went through a number of revisions where they scaled it down, and the code he wrote wouldn't have worked. He is the first person ever to have written a floating point math package. He used machine language, no assembly language, no compiler. It was just ones and zeros. And to make things a little bit easier, he used base 32. Most of us nowadays use base 16. Some of us remember the happy days of octal, but he was using base 32. The memory on this machine had originally been designed to be mercury delay lines. A mercury delay line is a long tube filled with mercury with a speaker on one end and a microphone on the other, and you send bits out through the speaker and they propagate through the mercury as acoustic waves, and then you pick them up with a microphone and you recycle them around. So this is rotating memory, very much like a disk, except that it's sound waves rotating and then being brought back electronically. That would have been the entire memory of this computer. The computer, the delay lines could remember 1024 bits. So you had to have a lot of these delay lines. That was one of the costs. Eventually, they decided that the delay lines wouldn't work too well, so they opted for CRT memory, cathode ray tube memory. Cathode ray tube memory is interesting. You take an electron beam. You've all experienced this if you ever had a television that you turned off and you saw the little white dot on the screen as it kind of petered out. Right? The screen remembers the charge of the beam for a second or two. So you can put a dot on the screen and it'll light up, and then you can sweep the beam across that area and put a little detector nearby, and you can tell by the number of electrons that get through whether or not there had been a dot on that screen before. So Turing, in his ACE computer in 1946, used that kind of memory, CRT memory. And it was the kind of memory where you could actually see the bits right on the screen. Little. And that's how he read out his answers. He would compute large numbers. He would read them out in base 32 off of the memory of the computer, these CRT screens. Eventually they added paper tape to the machine. The paper tape was way upstairs, and you had to start up the paper tape reader and then run downstairs and push the button on this massive computer. How many programmers were there in 1946?
You just said it.
3, 4, 5-ish. Yeah, you could count them on a hand, probably. I was born in 1952. That would have been, what, 8 years later? How many programmers in the world were there in 1952? Probably more than 100, probably not more than 1,000. The 50s was the era where IBM was selling the 703 computer. Anybody ever work on a 703?
Grandmothers count?
What?
Do grandmothers count?
Did your grandmother work on a 703? Real street cred here.
My grandmother's street cred.
Yeah, well, listen, so you're a third generation programmer. How many third generation programmers are there? How many of you are second generation programmers? Look at that. Okay. Your parent, one of your parents was a programmer. But you, 3 generations. There aren't too many.
I worked very hard.
Okay, yeah, okay. The 1950s, IBM sold 140 of these machines. The IBM 703. It was a vacuum tube computer, core memory. We'd gotten away from the bad idea of CRT memory, and had realized that magnetic memory was probably better. Let's say that I get to be 10 years old. It's 1962. How many computers are there in the world? It's a tough one. IBM had already sold all 140 of its 703s. Univac had sold a few computers by this time. There were also some companies in England and in Europe that had been selling computers. Perhaps there were 1,000 computers in the world. How many programmers were there? So it took far more than one programmer to keep a computer busy. Back in those days, you would write your code by hand with pencil on a piece of paper. You would submit it to some person who would punch it on paper taper cards. You would get those cards back and you would look at them very carefully. Then you would hand those cards, if they were all correct, you would hand those cards to a computer operator who would take the cards into the bowels of some room somewhere and pass them into the computer when the operator felt like it. The operator, by the way, had lots of other stuff to do. He had to run payroll, he had to run bill of materials, he had to run general ledgers. He had all this stuff he had to run, and your little deck of cards, your little compile, that went at the end of that. So probably it was the next day when you got a printout, and a printout would be on a table somewhere with your name on it, and you'd take it and you'd look through it and realize that you forgot a comma. So then you would submit the deck again. Now, the way that you made yourself efficient was to work on perhaps a dozen programs at the same time. So you'd work on one program, you'd submit that deck, you'd work on the next one, you'd submit that deck, you'd work on the next one, and you'd submit that deck, and that's how you kept yourself efficient. A single computer like an IBM 1401 computer that was being sold in the 60s would require a staff of 12, 13, 14 programmers. So if there were 1,000 computers in the world in the early 60s, there were probably tens of thousands of programmers. During the 60s, the mini computer was invented. The transistor became the electronics element. And then shortly after that, the integrated circuit became the electronics element. By heavens, say 1965, IBM had sold 10,000 1401s, model 1401 computers, with 4K of core. 4K on a 1401 was 4,000 words, 4000. The machine was decimal, including the address space. They used binary coded decimal inside the memory, and then they addressed everything in decimal. Everything was done in decimal, unless, of course, you were in England, and then they had a special little bit of electronics that could break it down into pence and shillings and so forth, but we can do that here. The IBM 360 began in the mid-60s. I don't know how many of these machines were sold. It cost IBM $4 billion in 1960 to develop the IBM 360 computer system, and it made them many dozens of billions of dollars. The IBM 360 series was massively successful. Tens of thousands of these machines were sold. Meanwhile, a little company in Maynard, Massachusetts started building PDP-8s. Over 70,000 of those were built and sold at a cost of about $20,000 each. Computers were starting to get into the range where a company could think about buying one and using it for whatever they wanted. And they needed programmers to do that. By the end of the 1960s, the early 1970s, how many programmers were there in the world? Now there were probably 100,000, 200,000 computers in the world. How many programmers were there?
Multiplied by 5.
Probably multiply it by 5. It's probably a reasonable thing. So, 500,000? By 1980, we had microcomputers. How many computers were there in the world in 1980? Now it's hard to count because the number starts to get nuts. By 1980, we're already beginning to see computers in little boxes scattered around the world. You know, the street lights now probably have a microprocessor in them by 1980, maybe 5, let's say. 1985, how many people had an Atari? In the 85-ish time frame, yeah? Everybody in the country had a little microcomputer at home. there were hundreds of millions of these machines. How many programmers were there in the world? Well, now the number of computers begins to get larger than the number of programmers. Maybe there were 10 million, maybe 15 million programmers in the world. 10 years later, 1990 something. Now we're into the super duper tiny little microcomputers. Microcomputers are now everywhere. Maybe there's 1 billion computers in the world. How many programmers are there in 1990? If you do the math on programmers, you'll find that the number of programmers in the world doubles every 5 years. And this has been true roughly since 1950. The number of programmers doubles every 5 years. And what that means is that half the programmers in the world have less than 5 years experience. And this has always been true and always will be true so long as the number of programmers doubles every 5 years. Our industry is stuck in a state of perpetual inexperience because the number of programmers grows at a rate which is much larger than you can gain experience. And people say, well, this is a job for young people. Only young people are programmers. Now, there aren't any old programmers. Whatever happened to all those old programmers? We're all still here. There just weren't very many of us. There's so many more of these youngsters now joining and buying. How many programmers are there? Look around the room. How many computers are in this room? And don't count the laptops, don't count the iPads, don't count the smartphones. How many computers are operating in this room at the moment, right now? Is there a computer in that exit sign? Probably got a battery in it. Charging batteries is more efficient if you've got a little digital signal processor in there that trickle charges and measures the voltage, makes sure that the current goes into the battery just the right way. There's probably a little digital signal processor running some C code written by some 22-year-old. Running in that exit sign right now, trickle charging that battery. What's that thing on the wall? It's got a red and a green light blinking. It's probably a motion detector. Software running in that? Oh, damn right there is. Yeah, that's sending out ultrasonic signals, moderated by some digital to analog converter. Running in there, it's got a little microphone, and there's some computer in there looking at the phase difference of the sound waves. Man, something's moving out there. What's that red thing? That's a fire alarm. Is there software in that fire alarm? God, I hope not. But there probably is. There's probably software in that thing. Is there a speaker? Yeah, speakers. Got software running in those speakers. Got to filter out the 60 cycle hum. It's cheaper nowadays to put a digital signal processor in there than it is to put an inductor and a capacitor. How many computers are there in the world? Hundreds of billions, probably trillions, maybe tens of trillions. The number of computers far outweighs the number of programmers. And the number of programmers is enormous. There's probably 100 million programmers in the world. Depends on whether you count the VBA people or not. Think about how often the average person interacts with software. They got a smartphone, because everybody does. They got a watch, it's probably software running in their watch. They got a microwave oven, there's software running in that. So they got a dishwasher, software in that. They got a washing machine and a dryer, software in that. How many lines of code in your car? In a modern car, there's 100 million lines of code. 100 million lines of code running in your car. My wife has a car that has a front-looking camera. It's got radar, it's got sonar, it's got all this stuff around it. But the front-looking camera is the interesting thing, because it can see the lane markings on the road. And if you drift over the lane markings at just the right way, and the car thinks, oh, she's falling asleep, it will yank on the steering wheel. There's servo motors in there that can turn the steering wheel. There's software in my wife's car that can turn the steering wheel, and that scares the living hell out of me. There's things out on the road out there right now moving at high speed. They've got lots of mass. The kinetic energy is terrifying. And they're controlled by little bits of software written by 22-year-olds at 3 in the morning. And you should worry about that. Our civilization does not yet understand how much it depends on us, you and me, programmers. We rule the world. We don't realize it yet ourselves, right? But we write the code that implements every policy, every decision, every machine that does anything, any law that does anything, any corporate policy that does anything. We write the code that implements those rules. We rule the world. If we could all get together, there's nothing the rest of the world could do. But I don't think that'll happen. It's kind of like herding cats. No, there's another problem that we are facing. And it's this problem. Our society has grown to depend on us much more than they realize and much more than we realize. How many bad things can now happen because of a software bug? How many people could die because of a software bug? There's code running out in those cars.
Well, people already died.
People have already died because of bugs in cars. It's a famous lawsuit, wrongful death suit against Toyota because of some bad software in their car. And the bug is fascinating. Never mind the fact that it killed people. The bug is fascinating. How many of you have done any real-time embedded work in little memory-constrained processors where you've got multiple threads running and you have to allocate stacks for the threads? And you allocate the stacks from the heap, and they have to be just the right size because the stack is going to grow and shrink and grow and shrink. And if you don't allocate the stack quite the right size, then the stack pointer will exceed the memory you allocated for it and corrupt somebody else's memory. And that's what happened in the Toyota case. They misjudged the size of a stack. One of the processes in just the right circumstances would push a couple of extra bytes into somebody else's memory. Turned out that the somebody else was the process that controlled both the accelerator and the brake. Note to future self, do not put the accelerator and the brake in the same process. That process froze, the accelerator down and the brake up, and the cars would go out of control and hit a tree and kill people or injure people. So several $1 billion got paid out on that. Knight Capital, who knows the story? You know the story, Knight Capital, a nice little company, New York City. Some poor schmuck had to add a new feature to a trading system. He was very careful about it. He went into the code. He said, oh, this is how I do it. I put an if statement here, and I wrap it around there, and I close it off there. And unbeknownst to him, what he had done, although it implemented the feature he needed to implement, it also caused some dead code that hadn't been executed in years, that should have been removed, but of course no one removes dead code. It caused this dead code to execute. Somehow he opened up a pathway, unbeknownst to him, to this dead code. Now, he was very careful. He didn't load it up on the whole server farm. He put it on one server. It was late at night, turned it on, everything seemed to work, and all of a sudden, they started seeing trades come through that were a lot of money. This dead code made bad trades, and other traders on the network sniffed the problem and started trading and trading and trading, and they couldn't figure out which machine to shut off. They'd walked away from it, and so they tried to figure out which machine to shut off. It took them 45 minutes, and they'd lost $450 million. $450 million, boom, some poor schmuck, some poor software guy, one dumb if statement, $450 million. The CEO woke up without a company. The vultures had already bought it out for him by the time he woke up in the morning. Do I need to talk about healthcare.gov? That's a really interesting case. Right? And then never mind how you feel on the politics of the situation. Here is a law that was passed by Congress, signed into law by the President of the United States, and was almost completely derailed by a software failure. It was that close. Right? And the software failure was obviously predictable. Do you think there were some programmers who knew that that program should not be turned on October 1st, 2013? Do you think on September 30th, 2013, there were a couple of programmers sitting there going, oh God, they're going to turn it on. They really shouldn't turn it on. But they're going to turn it on, aren't they? What happened to those guys? Did any of them speak up? Actually, we know that many of them did. We know that a lot of people spoke up. We know that the word train wreck was bandied around amongst the technical people, and it got into some of the politicians. And they still turned it on. What goofy set of decisions led to turning that on? So here's our problem. Someday, probably pretty soon, some poor software idiot's going to do some dumb thing, and 10,000 people will die. Like that. And you can imagine the scenario. It's not hard to think of one. None of us got into this to kill people, right? We all got into this because we like writing code. But here we are, with a society depending upon us, and lives at stake, and fortunes at stake, and some poor software schmuck is going to do some dumb thing, and 10,000 people will die, and the politicians of the world will rise up in righteous indignation, as they should, and they will point their fingers right at us, as they should, not at our bosses, not at our employers. They're going to point their fingers at us because it was our fingers on the keyboard. And they're going to say, how could you have let this happen? And we have to have an answer for that. Because if our answer is, my boss made me do it, that is not good enough. Well, we had to get to market. That's not good enough. And if that's our answer, then the politicians of the world will do the only thing left to them, the only thing they're good at, and they aren't very good at it. They will legislate. They will pass laws. And we will find ourselves being told what languages we can use, what platforms we have to use, what books we have to read, what classes we have to take, what process we must follow, what documents we must create, what authorizations we must seek. We will become civil servants working at the post office. I would like to avoid that outcome. But to avoid that outcome, we have to do something. We have to recognize who we are. We are professionals. We are the people who have been entrusted with the rules. They give us the rules as a set of requirements. We encode those rules in the machines. We are the people entrusted with the rules. And we have to behave in a way that is responsible to that trust. What does that mean? Well, it means a number of things. Number one, we need to have some standards. Minimum behavioral, ethical standards, things that we will do and things that we won't do. A standard little code of ethics. I don't know what this code of ethics is, but we're going to need it. I could make a few suggestions, like, it would be good if we wrote tests. But some code of ethics that allows us to say, when the politicians come to us, that we have this code of ethics. We have this set of disciplines. And we have a mode of enforcement so that when the politicians do point their fingers at us, we can say, look, guys, this was an accident, but it was not due to our negligence, because here's our set of standards, here are our disciplines, here's how we enforce these disciplines. This was not due to our negligence. And if we can say that, which we cannot say today, if we can say that, then perhaps we will avoid the worst of what the politicians will do to us. What is the definition of a professional? How do you know if someone is a professional? A professional is someone you hire to tell you what to do. You hire a doctor, and in this country we still pay our doctors through some circuitous route, but it does happen that the money comes out of our pocket and goes into the doctor's pocket somehow. The doctor is our employee. We go to the doctor after hiring the doctor, and then the doctor tells us what to do. You go to a lawyer. Right? You hire a lawyer. And the lawyer tells you what to do. Why? Because they have the knowledge. They know. They know what to do. You are programmers. You have the knowledge. You know what to do. And one of the responsibilities of that knowledge is the responsibility to say no. When it's not something that can be done, when it's not something that should be done, we are the ones who know it. Our bosses don't, our employers don't. They don't have that knowledge. We do. And it is irresponsible of us to not use that knowledge. We were hired for our ability to say no. That requires human-to-human communication. Something that, we all got into this because we like dealing with people, right? Put me in front of a computer all day long, keep all the people away from me, I'll just code all day. It's traditional in our industry that we feel that we are not as socially adept as other people. At least that's the stereotype, however true it may or may not be. But it is a skill that we all have to learn if we don't have it already, because we were hired for our ability to say no. We're hired for our knowledge, to communicate that knowledge to the people who don't know. Some of that knowledge I'm going to communicate to you tonight. I'm going to talk about the solid principles of object-oriented design. How many of you are programmers? Look at this. Okay, everybody's a programmer. Good. Anybody not? Ooh, what are you?
What's that?
What are you?
Business owner.
Business owner, not a programmer. Okay, and the other guy?
Business owner.
Business owner.
Project manager.
Project manager. I'm a business owner too, but I'm a programmer. And I like being a programmer better than a business owner, because owning a business is a pain in the butt. So, I'd much rather spend my time coding. So I do as much of that as I possibly can. You are all programmers, most of you anyway, except for 3 of you. And let's see, what's the most common language in the room? Let me see all the Java people. Ooh, we got Java people in the room. Let me see all the .NET people. Look at that. .NET people, you're all really Java people, right? Right, because same language, same platform, everything's the same except they switched some capital letters around. And added a keyword here and there. Fine, .NET, never mind, I'm not going to go through that routine. So, what else do we have? C++, man's language. C++.
Python.
What else? Python, good language, dynamically typed.
Scala.
Scala, derivative, well, it's not really a derivative of Java. It runs on the JVM, though. Ostensibly functional, but not really. If we want to be functional programmers, we have to use real functional languages. Scala is kind of a halfway step, What else? Ruby. Rails. Ruby on Rails. Surprising there aren't more Rails people in the room. Do I only have 1? 2? You've done some, yeah, okay, fine. This is the social networking language. All the social networking companies are using Ruby on Rails because they thought it was their key to going really fast. They were wrong, but it doesn't matter. I have seen entire companies purchased for the purpose of obtaining the Ruby programmers in that company. Screw the business model, tell all the customers to go to hell, we just want the programmers. And the price tag is about $1 million each, right? But some social networking companies were so determined to get their hands on a few dozen more Ruby programmers that they were willing to pay a few dozen more $1 million to get them. That's probably a bubble, and I wouldn't go running off and becoming a Ruby programmer just because of that, because I think that bubble will probably break, although it hasn't quite broken yet. Anyway, all of the languages that we just got done talking about are object languages. Why is that? How come they're all object-oriented languages?
Easier for us to wrap our head around.
Easy for us to wrap our head around. Now, When OO was first introduced to the industry in the late 80s, the complaint arose instantly from the C programmers and the Pascal programmers and all of these procedural programmers that this was far too complicated for mere mortal programmers to deal with. Objects are really involved and hard, and we shouldn't expect real programmers to do this. Only the mathematician types could ever get to be an object-oriented programmer. We're all doing it now. So they were wrong. It's not too hard. By the way, if you're worried about functional programming, I'll make the same argument. It's not too hard. And if you were programming in the early 70s, I could have had the same argument with you about structured programming, because the same crazy war got fought over that. What is object-oriented programming? When was it invented? 1966. 1966, the first object-oriented language was written. 20 years after the first computer was built, by the way. It was invented by two guys in Norway, Ole Johan Dahl, Christian Nygaard. They were writing a simulator in a language called Algol, which nowadays nobody uses, but it was very popular in the 1960s. Algol is a block-structured language, and I'll get into that in just a minute. The simulator that they were writing was a simulator that tracked ships in and out of the fjords. Oil had been discovered in the North Sea, right? Had to get those oil tankers in and out. So they were simulating the ships flowing in and out. And these two guys got tired of doing that. And so they did what any good geek would do. They started to hack on the language instead of the job that they were doing. Maybe we could change Algol to be a little more comfortable for this task. And so they managed to start hacking away on Algol, changing the language itself. And they invented a new language called Simula, Simula 67, they eventually named it, which had all of the attributes that we would today consider to be object-oriented. It had polymorphism, had inheritance, had encapsulation, had classes, had objects, all that stuff was in there. The keyword virtual was invented in Simula in 1966. All the C++ people, I'll tell you a little story about that in a minute. What happened? 1966, this was invented. And yet, it kind of languished. Nobody paid much attention. Why not?
Overhead.
Overhead. What kind of overhead?
The computers were not powerful enough to handle the environment.
Computers were not powerful enough to handle the environment. So this is the 1960s, right? In the 1960s, a really good computer might have 8K. So we were tightly memory constrained. And an object-oriented computer probably needs a heap, because you've got to allocate objects. Well, if all you've got in your computer is 8K, you're not going to have much of a heap. And you really can't afford to be flopping things in and out of the heap if all you got is 8K. Right? So maybe there's not a lot of room in your computer for objects. So we have to go forward about 20 years. 20 years, 1988, 1989, now we've got computers that can handle this. And objects begins to become more interesting. Where did C++ come from? Who invented it? Johannes Druster. He's Danish. When did he invent it? 1978. He wrote a paper in 1980 called C with Classes. In 1983, he changed the name to C++. In 1986, he wrote the very famous book, the C++ programming language, that convinced all the C programmers in the world that this was the language they should all be using. Jarne, prior to that, had been in Edinburgh as a student programming in Simula. And when he got to Bell Labs in New Jersey in the late 70s, they said, well, you're going to have to program in C. And he looked at C and he said, no, I'm not programming in that language. I got a better language, Simula. And they said, no, you're not doing Simula. And he said, oh, yes, I am. And he wrote a little preprocessor in front of C that made C look like Simula. And that's why C++ has the keyword virtual. Many of the concepts moved from Simula into C++. The other object-oriented language that got started back then was Smalltalk. Smalltalk was started in the late 70s by a guy named Alan Kay. Alan Kay had been a Simula programmer. And then he went to Xerox PARC and he learned a few things, and somebody decided to have a challenge to write a small object-oriented language in less than a day. And the guy who worked for Alan Kay came back a day later with Smalltalk. And then they built on it and built on it and built on it. Smalltalk became the other object-oriented language.
Sounds like JavaScript.
It is remarkably similar to JavaScript. The original author of JavaScript wanted to write Lisp, but he didn't have enough time, so he did this bastardization of the language self and kind of dumped it on the world, and now we have JavaScript. Many of our languages came from a session like that, where some other programmer just didn't like the language they were using and did something to hack it and turned it into another language. How many languages started that way? C. C was just a derivation of another language called B, right? Which was a derivation of another language called, not A, right? BCPL. Algol turned into Simula, C turned into C++, C++ turned into Java and C#. All of our languages are really just kind of evolved from other languages. There's this lovely tree of inheritance all the way back to Alan Turing. What is an OO language? I just talked about three of them, C++, Simula, and Smalltalk. What is it that makes a language OO, other than the two O's? Got a lot of people here in the room, all object-oriented programmers.
Algorithms for an object to reside together.
Data and the algorithms for an object reside together. What the hell does that mean? They reside together where?
And the object.
In the what?
The object.
In the object. What's in the object? Here's the memory of the computer. What's in that memory? This is the space for an object. Let's call it a car. This is a car object. What's in that memory?
Pointers.
Some variables, maybe some pointers. Is there any code in there?
Instructions.
Any code in the memory of the car? No. No, the code is over here, right? Now the code is in the class. And the class gets compiled down to a bunch of code which has functions in it, and then there are interesting pointers over here that point at the functions in the class. And when we call a method on a car, so here's somebody else who calls a method on a car, it calls it through that pointer. So if you call the drive method on a car, it goes to the car object and says, okay, where's that drive method pointer? Oh yeah, there it is. What function does it point at? Oh, this one. Okay, call it. The code and the data don't live together in the computer. Do the code and the data live together anywhere? In the source code? They're kind of associated in the source code. In the source code, we managed to do this kind of thing, right? Class this, and okay, and some methods, and oh gosh, you know, if this is C++, then that's a .h file, and we've got to put the real code over here in a completely different file, so they don't live together at all. Now in Java, we said, ah, the hell with that, we're going to just put all the code right in here. What if I have a derivative of car? What if I have a class electric car? But it derives from car and has a drive method. So there's a function drive different from this drive. And now I've got a user out here. And that user calls the drive method on car, and it doesn't know that it's an instance of electric car. It just knows that it's an instance of car, and it finds the drive method pointer and calls it and has no idea that that pointer is pointing at the electric car's drive. That's how we implement polymorphism. That's how we get the polymorphism, by using those interesting pointers to functions. What else is the definition of an object-oriented language? What are the three magic words?
Inheritance.
Inheritance is one of them. What's another one?
Encapsulation.
Inheritance, encapsulation, polymorphism. Let's take a look at encapsulation. Did O.O. give us encapsulation? No. O.O. did not give us encapsulation. In C, we had perfect encapsulation. In C, I could write struct point. I could put this in a file called point.h. Inside struct point, I could just forward declare it there. I didn't have to even define it. I'll just forward declare it in point.h. And I'll also forward declare something else. I'll forward declare a point star make point. Takes x and y, but I'll just forward declare it. I won't implement it. And I'll forward declare a double distance, taking 2 points, point star p1 comma p2. My syntax is not correct, but you know what I mean. And now in point.c, completely different file, I can define all of that stuff. Struct point double x comma y. Always remember your semicolons after closing braces in C-derived languages. I could do my make point here, so point star make point takes an x and a y, and we will implement that to allocate some memory off the heap or something, and we'll have a double distance taking 2 points and implementing it to do some interesting thing. Clients of point know about which of these two files? Point.h. Do they have any visibility at all to the members of point? No. They can't have any visibility at all to the members of point. This is perfect encapsulation. Absolutely perfect. We did not have public, we did not have private, we did not have protected. We had none of those horrible keywords. We had absolutely perfect encapsulation. O.O. broke that entirely. When we got O.O., we had to break this. Why? Because C++ forced us to put the variable definitions in the header file. Had to do this for technical reasons, but it broke encapsulation. So now we had to add keywords, ugly keywords, public, private, protected. Those are horrible hacks that try to restore some modicum of the encapsulation that we lost. O.O. did not give us encapsulation. It took it away. It weakened it. I'm not even going to consider that as an element of an O.O. language because they're all badly broken. Java just gave up. Just put it all together. What the hell? And of course, C# followed suit because C# is Java. The next one on there is inheritance. Did we have inheritance in C? Not exactly. Not exactly. Although it wasn't hard to do. In C, it would have been very simple for me to create yet another struct called named point. And of course, I have a header file for it, so named point.h. And in named point.c, I could create the struct named point, and I would do it so that the first elements were the same. So I would say double x comma y, and then I would add a new element like char star name. And the interesting thing about this is that I could create an instance of a named point and pass it to that distance function. Because I could cast a named point to a point, and everything would work out fine. This is, in fact, how C++ does casting anyway. So it was very simple to do, and we C programmers did this kind of stuff all the time. We called them discriminated unions back then. We didn't call it inheritance, but same idea, same basic function. So what I'm going to say about inheritance is that O.O. gave us some convenience. I'll give it half credit for this. Because once we got to C++, we had the nice little colon, and we could actually do real inheritance, and that made it a little easier. We didn't have to do the casting that you would have to do in C. Made it a little easier. Okay, half credit for inheritance. Polymorphism. Could we do polymorphism in C? No. Well, actually, we could. Remember, I'm gonna write a little Unix program here called copy. Int C, let's see, while C equals getChar. Everybody remember the getChar function? All right, not equal EOF, put char C. There, I think that works. Reads a character from, what's getChar do? Keyboard? Standard in, which is usually the keyboard. But it doesn't have to be the keyboard. I could change standard in.
Redirect.
I could redirect standard in. That's polymorphism. This is an object-oriented program. It's polymorphic. getChar is a virtual function on a class-named file. It's not written that way because it wasn't written in C++, but that's how it behaves. And how did the Unix operating system manage to get getChar to finally go to the right I/O driver? Remember, right? getChar is going to get a character from somewhere. Let's say it's the keyboard. That means getChar's flow of control is going to somehow have to get into the keyboard driver. How did that happen in Unix?
Virtual tables.
Virtual tables inside the file data structure. Every file had 5 pointers to functions inside it. Open, close, read, write, seek. If you wrote an I/O driver, you had to write those functions, correct right down to the signatures, and then those function pointers would get loaded into the table inside the file. And when you called getChar, it would go to that function pointer in the table and say, oh, call the read function, and it would go to the right driver. Same kind of polymorphism that you see here. So we had that in C. But we didn't do it much. And we didn't do it much because it was hard. It's hard to flip around pointers to functions. You've got to remember to initialize all these horrible tables. And if you're writing in C, well, if you've ever written C and you're dealing pointers to functions, you know there's all kinds of parentheses and stars, and you never can get them in the right order. And then you finally kind of stick them into variables and you hope they're right. And then you also hope that nobody else calls the functions that you want to be polymorphic directly. Because if they do, then they invalidate the whole scheme. So it's very difficult to get polymorphism to work in a C environment unless you've got a really firm boundary like the operating system. Which is why we could do it across the operating system boundary easily, but we couldn't do it anywhere else. C++ changed all that. C++ made polymorphism easy, safe. It loaded all the pointers for us. It did all the casting for us. It made sure that when you called a function, it went through the tables. So all of a sudden, polymorphism became trivial. Why are all of our languages object-oriented? Polymorphism. Not encapsulation, not inheritance, polymorphism. Polymorphism is the one thing that O.O. gives us that we did not have before. Yes?
Technically, you need inheritance for polymorphism, right?
Ooh, do we? In statically typed languages like C++, Java, and C#, polymorphism depends upon inheritance. But in dynamically typed languages like Ruby or Smalltalk or Python, no inheritance is necessary. And in fact, inheritance is a kind of backwater relationship that hardly anybody uses in those languages. Right? We just don't inherit much in Ruby, every once in a while. If you want to think about it, think about inheritance in Ruby as being roughly equivalent to private inheritance in C++. It's for inheriting implementation, but not for polymorphism. So, yes, in a statically typed language, we need inheritance to get polymorphism. What is the strongest relationship we've got? In a statically typed language, what is the tightest coupling you can have between two classes? Inheritance. Because if you inherit from a base class, you depend on everything inside that base class and everything it depends on. You can't forward declare a base class if you inherit from it. You can forward declare all the classes you use. But you cannot forward declare something you inherit from. So this is a very tight coupling. And yet, it's the coupling that gives us polymorphism. Statically typed languages live in this bizarre world where the relationship that provides flexibility is the tightest coupling we've got. So we have this real strange mixture of rigidity and flexibility in statically typed languages. Dynamically typed languages abandon that. Right? Which is why there's a lot of people who do dynamically typed languages. It's a lot easier to write code in a dynamically typed language. A lot of studies have been done on this. Dynamically typed programmers typically get things done 5 times faster than statically typed programmers. For whatever reason. And maybe it's not 5, maybe it's 4, maybe it's 3, but nobody thinks that a Ruby programmer is slower than a C++ programmer. So now we've got polymorphism. Why is polymorphism good? What great thing does polymorphism do for us?
Abstraction.
Inject dynamically at different types,
We can dynamically inject different. Well, what good is that?
so that you could have a different implementation. Yes.
Different implementation. So I can have this. I can have some user out here, and that user uses some interface, and I'll use the Java definition or the .NET definition of the word interface here. And I can have several different derivatives of that interface. And this user does not need to know which of those implementations it's using. Why is that valuable?
Because it's expensive, but it's so it's code use.
So let's go back to the copy program. This one over here. Imagine that I had not written it this way. Imagine that I had written this copy program this way. In fact, I'm going to rewrite it. Reads from the keyboard, writes to the printer. Not using getchar and putchar, but calling directly to a function that reads from the keyboard and calling directly to a function that writes to the printer. Now my boss comes to me and says, you know, sometimes we'd like it to read from the paper tape reader. How long is it going to take you to make this change? We think about it for a while and we say, well, 3 weeks. That's the minimum estimate, right? We're not allowed to give an estimate less than 3 weeks. If anybody gives an estimate less than 3 weeks, then all the other programmers come to our cubicle with clubs. Right? So boss goes away happy, he got the minimum estimate, 3 weeks, and now we look at this and we say, okay, how am I going to make this read from the paper tape reader? Now that means I got to pass in some kind of flag or something. And I could go in here and I could add a Boolean flag, but why am I not going to do that? So all the other people using the copy program right now would have to recompile and retest, and they're not going to tolerate that. They take and beat us up overnight. So we can't change the signature of the function because too many other people are using it. But that's okay. There's always a way to get new information into a function. We'll just use a little global here. GPT flag equals false. We're going to initialize it to false because we're not doing the paper tape, right? And the whole idea here is that if you want to read from the paper tape reader, then you have to set that to true first, then call copy, and then you'd better remember to clear this because the next guy is going to depend on that. So put a little comment in here, remember to clear, which covers our butt. Okay, now, right here, and let's do this in a different color, because we can get the red one. Yeah. Just gonna get the red one here. Right in here, we're going to say GPT flag question mark RDPT colon right in there. I like question mark colon. And this works. And we ship it, and life is good. And our boss comes to us a few weeks later and says, you know, sometimes we'd like this to write to the paper tape punch. Well, we've got a little design pattern cooking here. We know what we need to do. So, you know, a little Boolean. And punch flag equals false. We can reuse the comment. Let's see, right here we're going to say G punch flag question mark word punch C colon right in there. How many of you have done this? Huh? Put a little if statement in, right? Okay, oh, another feature. I'll put a little if statement in. This is a little flag. It might have to be a global, but that's all right. You know. Notice what would have happened if we had used getchar and putchar. If we had used getchar and putchar, then when our boss came to us and said, you know, sometimes I'd like it to read from the optical character reader, we had an option. We could tell him that it already does, or we could say 3 weeks. Either way, we're a hero. He comes to us and says, you know, sometimes I'd like it to write to the voice synthesizer. About 3 weeks. It already does. The changes our boss has asked us to make require no change to the code if we use the polymorphic functions. I don't even have to recompile it. The binary still works. All I have to do is redirect standard in and standard out. That's the benefit that we get from polymorphism. This is the benefit we get from OO. When a requirement changes, we don't have to do anything. Sometimes this is called the open-close principle. The open-close principle is a very simple principle. It says, design your system such that when the requirements change, you don't have to change any of the existing code in the system. All you have to do is write new code. Right? And that's exactly what I would have to do if I used getchar and putchar here. Because if I used getchar and putchar there, then when he came along and said, well, sometimes I'd like it to read from the optical character reader, all I have to do is write the optical character reader driver. I don't have to change this at all. No new code gets, no existing code gets changed. That's the open-close principle. No existing code gets changed. How do you do that? Let's go back in time. 1960s. 1970s. Before we're doing OO. Anybody programming in the 1970s? Yeah, guy there, guy there, guy there. Well, okay, the rest of you are young. All right, so back in the 70s, there was this thing called structured design that we all learned. We got taught by Ed Jordan. Ed Jordan, who said, oh, structured analysis, structured design. Here's what structured design. In structured design, you would design your application to have a main function, and then the main function would call high-level functions, and the high-level functions would call many mid-level functions, and the mid-level functions would call lots of low-level functions. Now, which of these source code modules knew about the others? Did HL know about main? No. Did main know about HL? Yes. So the source code dependency pointed in that direction. And that was true all the way down this hierarchy. And at runtime, which of these functions knew about the others at runtime? Or another way to ask that is, which direction did the flow of control travel? And the flow of control traveled from main to high level, and from high level to mid level, from mid level to low level. The source code dependency pointed in the same direction as the runtime dependency, which meant that your source code architecture had to be the same as your runtime architecture. But O throws a nice little curve into that. Because when you have polymorphism, you can do this. I have some module. This module uses some other module, which I will call N. Written that way, the source code and the runtime dependencies point in the same direction. But I can do this. Module M uses an interface. Module N implements that interface. And now I have this lovely situation where the flow of control still goes from M to N. M calls some function in N. But the source code dependency points against the flow of control. And because of that, my source code architecture is no longer constrained to the runtime architecture. I can have a source code architecture that's completely different from the runtime architecture. I am absolutely free to take any of these relationships I want to and flip them around. Now look at those relationships. They should bother you. The ones over here. High-level policy depends on low-level policy. That should bother you right away. Just saying that should bother you. Do you want your high-level policy depending on its implementations? Do you want high-level policy depending on low-level policy? The answer to that is obviously not, because you want to be able to change out the low-level policy without affecting the high-level policy. And yet, if you're stuck in a procedural world, high-level stuff must depend on low-level stuff, both at the runtime level and at the source code level. You're stuck with it. But if you have OO, well, then you can isolate your high-level policy from your low-level details. That's exactly what we did in the copy program when we used getchar and putchar. Getchar and putchar hide the low-level implementations. Getchar and putchar in that copy program create a copy program that is nothing but high level, with no low-level dependency at all. Getchar and putchar don't know that the keyboard driver exists. How many of you are using an IDE? And Java people, you are using, let me guess, Eclipse?
No.
No. What else?
IntelliJ.
IntelliJ. Oh, that's the good one. That's the one I use. IntelliJ is the best. Eclipse is the second best. By the way, why is it called Eclipse?
Sun.
Sun.
IBM.
Yes. It was just right, yeah. It was produced by IBM to block out the sun. It worked. That was business strategy. I know the guy who invented that business strategy, and it worked. Sun is no more. .NET people, what IDE do you use? Because there are so many to choose from. Yeah, okay. It's great living in a monopoly, isn't it? So, do you use ReSharper? Yes. Which is made by the same people who make IntelliJ. Right? So it makes Visual Studio almost usable. Now, what is the source code architecture of Visual Studio and ReSharper? So here is Visual Studio. Here's ReSharper. Which of those two knows about the other at the source code level? Does Visual Studio have code in it that knows that ReSharper exists? Does Microsoft deign to acknowledge the existence of those idiots in St. Petersburg? Right? No, of course not. Microsoft is Microsoft. They don't care about those guys in St. Petersburg. So ReSharper must know about Visual Studio. At the source code level, there are header files over here that these guys have to import. But who calls who? Who has control? First, Visual Studio calls ReSharper. So the runtime dependency is that way. Source code dependency is this way. It's exactly what we're doing here. And they use the exact same mechanism to give us a plugin. Which of these two companies can screw the other one? Microsoft can screw IntelliJ. That's the name of that company now, JetBrains. JetBrains. The name of the company used to be IntelliJ. The name of the IDE used to be IDEA. But no developer called it IDEA. All the developers called it IntelliJ. So they changed the name of their company. This was a smart thing of them to do. So JetBrains can be screwed by Microsoft. Because Microsoft, all Microsoft has to do to screw these guys is change their header files around every month. We don't like these guys. We want to put them out of business. What can these guys do to put Microsoft out of business?
Implement better features.
Yeah, make a better IDE. I wish they would. But okay, they haven't done that yet. There's nothing within that relationship that JetBrains can do to Microsoft. JetBrains is powerless. Microsoft is all-powerful. Now, within your systems, do you have code that you would like to protect from other code? Within your systems, is there code that you would like sitting here in a position of power where it cannot be thwarted or messed up by these guys? And of course you do. They keep on changing the iPhone, you know. They send you another iOS release every once in a while. And about a year ago, they sent me one that changed all the icons. They used to have these nice three-dimensional icons, and you'd look at it and think, yeah, there's texture there, it's nice. And then about a year ago, they changed them all to flat icons. Why'd they do that?
Because they like Microsoft.
Because they like Microsoft. Some marketing weenie went, whoa, man, we've got to change all our icons. Now, I hope that the software developers had been smart enough so that they didn't have to go change all their code just because the marketing weenies changed their icons. Anybody here ever had to reach deep into the guts of a system to change the way a report was generated because some marketing weenie didn't like the spelling of a word or the punctuation you might have or the order of two columns? There are parts of our system that are volatile. They are meant to be volatile. We want them to be volatile. We want the marketing weenies to fiddle with that stuff. Please, fiddle with that stuff, but leave our business rules alone. Put all that stuff out here, all that formatting stuff and all that GUI stuff and all the stuff that you want to be flexible. Put that out here because it can't mess with these guys. There's nothing that can happen out here that can hurt the business rules. You take the business rules, you put them on this side of the equation. Say, okay, nothing touches them. What kinds of stuff are volatile? What kinds of things are volatile? UIs, classic UIs. So this is why we don't like SQL in our UIs. This is why we don't want the UI to know about our business objects. We don't want to take a data structure all the way out of the database, pass it through an ADO, and the DTO goes clunkety, 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 clunk all the way over to the GUI, where the GUI depends on it, and you break this model. You want the GUI isolated as far away from the business rules as possible. What else changes a lot that has nothing to do with business rules? Data. The structure of data. The structure of the data in the database. Has anybody had to make a crazy schema change? Had nothing to do with the business rules in your application, but some DBA decided to screw around with the schema and flip things around, and you're writing code for 3 weeks because of this. You would like your database drivers over here, who's using something like Hibernate, N-Hibernate, or some, what do they call them? ORMs, which stands for
Can't code SQL.
Object Relational Mismatch. Good. Object Relational Mapper. There's no such thing as an Object Relational Mapper. Right? Objects and relational databases don't map because objects are about behavior, not data. When you look at an object, all you can see is functions, not data elements. You don't know if there's any data elements in there, right? Because all those data elements are private. You're not allowed to see them. Data structures in a database have nothing but data. There's no behavior in them. There's no mapping between the two. They aren't the same. So the idea of an object relational mapper is a misnomer. What an ORM actually does is takes the data structure off the disk in whatever bizarre format it happens to be on the disk, and it puts it into memory as another data structure. ORMs just hide data structures. I want all that stuff happening over here. All that stuff I want over here so that the only thing that manages to cross this boundary are the final data structures that are hydrated out of the database. I don't want any of this code over here to know about SQL. I don't want it to know about the schema of the database. I don't want it to know about anything else except the final data structures that are created from the database. What else is volatile?
Government regulations.
Now, unfortunately, they are also your business rules, so you're completely hosed. If you're implementing government policy, you are going to be thrashing your business rules left and right because they're going to change the rules on you all the time. Although it's possible that you can separate those rules that don't change often from those rules that do, and those parts of the rules that don't change often from those parts of the rules that do, and you could make plugins for the more volatile parts of the rules. Plugins, I use the word plugin. When you're doing object-oriented design, what you are doing is creating a plugin architecture. You are separating volatile things from static things, things that change frequently, from things that don't change frequently, and you put the things that change frequently in plugins, and the things that don't change frequently get plugged into. What else doesn't change? Or what else does change? What else changes frequently?
All I/O.
All I/O. All I/O. What is the web? The web is an I/O device. It's an input-output channel. It happens to be fairly fancy, but that's all it is. It's an input-output channel. What did we learn way back in Unix days? Get char, put char. Be independent of the I/O channels. We think we are writing web applications. The instant we have said that, we have failed. Because we are writing applications that happen to use the web as an I/O device. But the web is just an I/O device that we'd like to stay independent of. I don't want this stuff here to know anything about the web. I don't want it to know anything about web pages, web forms. I don't want any webby kinds of stuff in here. That can be out in one of these plugins. I want the web to be a plugin to the business rules. To the extent that if I wanted to rip the web out and put in a console app, it would just be another plugin. Or if I wanted to put in a desktop app, it would be just another plugin. And the business rules wouldn't change. It was using dependency injection. Cool, everybody. Dependency injection. So cool, isn't it? Right? Somebody came up with that, what, about 8 years ago? Whoa, man. Dependency injection. We got to have a framework for it now. What framework?
Unity.
Unity, Spring. Man, you got to have it. Okay. And
No framework.
no framework, just you pass it through constructors and setters. The old-fashioned way. Real magic. Frameworks. Dependency injection frameworks. How many of you have made the mistake of injecting far too much and you lose control of the whole injection architecture? Maybe you've got some horrible XML file that you've lost control over. You build the system, it fails for horrible reasons. You realize, oh yeah, I forgot to change this thing in the injection. When you've done that, you've gone too far. How much stuff should be injected with the framework? Well, let me put that differently. I don't want this code to know anything about the framework. I don't want any imports of the framework going into that code. I don't want anything injected by the framework into that code. Now, I don't mind if you inject out here. In fact, there's a little plugin out here called main. Main is your main program. Main is where you do all of your initialization and all of your setup. It's a plugin to your business rules. And you can inject anything you want into there using some kind of DI framework if you wish. But then, from here out, you will use more traditional means to inject your dependencies without the benefit of the framework. Why? Because framework authors are out to screw you. Framework authors do not have your best interests at heart. They have their best interests at heart. Framework authors don't know you. They never will. They're just writing code. And they're very happy to write code. And it gives them great pleasure if you bind yourself as tightly as possible to them. Doesn't hurt them at all. They can completely screw you. Anybody been screwed by a framework recently? But you can't do a thing to them. It's a very asymmetrical relationship. You are powerless. They are powerful. So here we got a bunch of engineers in the room. What do you do when you get a power mismatch? All right? Well, you isolate it. You say, okay, these framework guys, they're good guys and all, and they're trying to help out, but they could do something to me tomorrow that would completely turn me upside down. So I'm going to put them outside of a little boundary here. I'm going to put them outside of a little layer. I will let them into my layer, but my business rules, they're not touching my business rules. I'm not putting any of those funny, who's using Spring, Java, Spring, any of those little @ auto-wired things. Don't want those auto-wired things in here. Put them in here, that's okay, not in here. You got other little annotations in .NET, funny little square bracket things that you're doing. Don't want that stuff in here if it's tied to the framework. In fact, I want no import of a framework into the business rules. The stuff that is really valuable, the parts of the code that make or save the business money, the family jewels, the business rules, you keep as isolated as possible from any foreign influence. And you do that by using these rules. Now, we've been at this for about an hour and a half, and I've talked about one principle and some history and some other stuff. There's a whole bunch of these solid principles. I've talked about the open-close principle. There's a whole bunch of others. Probably we shouldn't go on much longer than this, though. So let me ask you this. Are there any questions about what we've talked about today? Seth?
How do you actually put it all in practice, given the test-driven development and the dependency injection and the unit testing was known to test the insides of the code, and the requirement testing, which is the outside of the code, and how to transition from the requirements testing, which gives you the API, into the unit testing, which gives you the implementation of it. What's the best rule of thumb so you don't have to rewrite the test and correct yourself and realize that you were a lot deficient?
Who's doing test-driven development in this room? So we got one of these, and we got a smattering of others. Okay, and if this had been a Java crowd, it would have been about 1/5. This is a .NET crowd for the most part, so it's much less than that. And that's, by the way, very traditional. The Microsoft community has been, over the last decade or so, much more insular than the Java community. The Java community tends to look out more, the .NET community, the Microsoft community tends to look in more. Just because that's the way it is. That's the culture of these two different communities. Test-driven development is a discipline where you write your tests first and then you make them pass. And you do that in a set of extremely short cycles, 5 seconds long. You write a bit of a test and then you make it pass with a bit of production code. Then you write a bit more of a test and you make it pass with a bit more production code. This is virtually identical to double-entry bookkeeping that accountants use for the exact same reason that we do test-driven development. To make sure that we don't do anything stupid, that we have cross-checks. Accountants add everything in 2 places, once on the liability side, once on the asset side. Every transaction gets entered twice. They follow separate mathematical pathways until there's a subtraction on the balance sheet, has to yield a 0. And the accountant will add a transaction here, do the sum, add a transaction there, do the sum, subtract 0. Good, that transaction's okay. Next transaction, enter, sum, subtract. Enter, sum, subtract. They don't enter 50 transactions over here, then enter the 50 transactions over there, do the sum, subtract 37. They don't do that, hopefully. Test-driven development is the exact same discipline, except instead of putting something in numbers on the asset side and liability side, one is a test, one is production code, and they follow the exact same format. People complain, they say, well, test-driven development, we don't have time to do that. Do accountants have deadlines?
Yes.
Are they under pressure by their managers? They must deliver the spreadsheets? They're critical? How is it that they have time to do double-entry bookkeeping? No accountant in the world would say, oh, hell, we've got a deadline. Okay, do all the assets, screw the liabilities, we'll come back to them later.
It's systemic.
It's systemic. Yes, it is. It has become systemic. It took 500 years to become systemic. Double-entry bookkeeping was invented 500 years ago, probably because accountants were losing their heads, literally. And bit by bit, over the course of time, it has been propagated to the rest of the world. The last country to adopt it as law did so in roughly 1945. So it took a very, very long time for this to achieve this force of law. Test-driven development has not yet achieved the force of law, but it easily could. We should adopt it before that happens. You said, okay, how do I do all of this stuff in the context of test-driven development? How do I do all of this in the context of acceptance tests and requirements testing? And the answer to that is, this kind of stuff is done at 2 times. How many are doing Agile? What kind of Agile is it?
Safe.
Safe.
Okay, let me clarify. A tempting.
Yeah, okay, never mind. Scrum, save, well, yeah, fine, Agile. And what is your iteration size?
2 weeks.
2 weeks, 3 weeks. Okay, 2 weeks. 2 weeks is a good number. I like 1 week better. Some people like 3. Too much can go wrong in 3 weeks. And what are you supposed to get done at the end of every iteration?
Deliverable projects.
It should be deliverable. It may not be delivered, but it should be deliverable. From a technical standpoint, everything is done. All the QA is done, all the documentation is done, everything is done. There's no little burn-in thing that happens later. QA doesn't sit there and say, oh, but we need 3 months of burn-in. That doesn't happen because all the burn-in's been done in the cycle. If you're doing Agile, when do you write your requirements tests? At the beginning of each iteration. At the beginning of each iteration, the business people, QA people, programmers to some extent get together. They write a set of automated tests that test the features that will be implemented in that iteration. And you know that the features are done when the tests pass. This is how we know that things are done. The tests pass. It's the only criteria we have. If the tests pass, the features are done. The stories are done. At the beginning of the iteration, we also do something else. We have a little design session. There's been a lot of controversy about this over the years. People have said, oh, when you're doing Agile, you don't do any design. No, you do design. You just don't do an awful lot. You do enough to cover a week or 2. So you have a little design session at the beginning of the iteration, and that usually means standing at a whiteboard and scratching a couple of diagrams on there, and everybody looks at it and says, yeah, probably. And in the midst of that, you have probably done some of this work. Some of it. And then you begin to work. You begin to do test-driven development, to design your classes. You make some requirements tests pass, some acceptance tests pass, and inevitably you will come across a design flaw, something you did wrong. And in the midst of the iteration, you think, this design doesn't work, and you start to refactor. You start to fiddle with it and move it this and change that and change this. By the time you're done with the iteration, these pictures will have all subtly changed, sometimes dramatically changed. That's a good thing, because that change was informed by real code being developed by real developers at the time. So the design continues to go. These kinds of decisions are made throughout the iteration, throughout the project. They're made at all times. They're made whenever you refactor or whenever you do a design session. They're made all the time. They're not done up front. They're smeared out through the whole development process. You asked a very specific question. You said, well, how can I do this without changing all my tests all the time? And the answer to that is design your tests better. We tend to think of tests as second-class citizens. The code is what's important. The tests, well, the tests, we write some tests, whatever. But when you treat your tests that way, they rot. They get rigid. Think of it this way. If you have a change to your system that causes 20 other modules to break, you've got a design problem. Now think of those 20 other modules that broke as tests. You still have a design problem. It's a design problem to keep your tests from breaking all the time. And that's what we do. We are designers. So we have to design our tests to be less coupled to the system, and we have to design our system so that it's less coupled to itself, so that we keep the whole system, including all the tests, as robust as possible. Ooh, that was a long answer to a short question.
Eric from the live stream has a question. He said, can you give an example of an interface segregation principle?
Can I give an example? No, because that would probably take us about a half an hour. And I don't want to do a half an hour. So I'm sorry, Eric, but I can't do that one now.
Yeah.
Quick one.
Yeah, just wondering, where the solid words come picture.
Solid.
Yes. You invented this acronym?
Well, no, I didn't invent the acronym. Let me tell you how that happened. Long ago, I wrote down a bunch of principles because there was a guy on the net named Ian Fleming. This would have been 92 or something like that. And he wrote a post on comp.object, which was an old news group before we had Facebook. And he said, the 10 Commandments of object-oriented. And I read the 10 Commandments, and I thought, no, that's probably not a good set of 10 Commandments. So I wrote this, and I wrote the open-close principle, which is a Bertrand Meyer invention. Bertrand Meyer came up with this a long time ago. The Liskov substitution principle, which was invented by Barbara Liskov in roughly 1988. The dependency inversion principle, and a few others. Over the years, I added another one, which was the interface segregation principle. That one came around about in 1995, 96, something like that. A little bit later, we added another one, which was the single responsibility principle, which is another Bertrand Meyer principle. And then one day, a friend of mine, his name is Michael Feathers, said, you know, Bob, if you change the order, it spells out solid. And I said, yeah! That's how it came to be solid. Completely unintentional. Last question.
Hey,
Sir.
on your open-close principle, how do you keep, especially as you're doing TDD and getting in more of the automated acceptance test, how do you keep from over-architecting too? Because that's another downfall I've seen of you extract everything so much that it gets to the point it's not even maintainable.
Yeah, so good question. How do you avoid over-abstracting, over-engineering? And the answer to that is real simple. You only put in the abstractions that you need, that you provably need. So you don't put in abstractions that you anticipate that you might need. You wait until you actually need them, and then you put them in. You will find that you will put a lot of them in just because you're writing tests. The tests will need a lot of abstraction so that you can decouple your production code and get inside it and access it from unit tests. And then you'll also find from time to time that there are changes that people make, and you'll look at your code and go, man, I didn't protect myself from that. And so that's when you do it. You go back and you refactor that abstraction in. It's pretty reactive. There's a little bit of upfront design work at every iteration, some small bit of anticipatory design, not very much. A little bit of abstraction that you think you're going to need, but not very much. We start to over-engineer when we spend a lot of time designing and not a lot of time implementing. Has anybody had the experience that they spent months designing and then they wrote the code and saw that the code had nothing to do with the design, whatever? The code came out in some completely different form. Well, we'd like to prevent that from happening. So we do that in real short cycles. And with that, I think I'll say good night. Thank you all for your attention. It's been fun. See you another time.
Let me go get Joel. We're back. Okay, so yeah, we got 2 JetBrains licenses to give away, $50 Visa gift card, and some trial memberships, month-long trial memberships to Pluralsight. I got a couple coins too. So, yeah. Does anybody else want to put their name in before we get started?
Yeah, has anybody not filled out a raffle ticket?
I'll put mine in again.
No, you can't do that.
I have to fill some, I just got a ticket.
Yeah, if you can do the other half.
Oh, okay, I didn't fill anything out.
Oh, wait. Oh, so what did you do with the other half of the ticket though?
Huh?
You put the other half of the ticket, you put it here?
Well,
They didn't do it. You just
given
wrote
to
your
me.
name on it.
I don't know, it's not important. There's a number on it, I guess.
Yeah, but the other half of the ticket is in here.
I hope so.
I hope so too. All right, you want to draw?
It's fine.
All right, so can you have the,
And I actually have the license numbers already, so I can just give them right away.
so,
This can we apply Visa? Okay, so the Visa gift card is Jim Sim.
yeah, Jim Sim.
Jim Sim? All right.
Thanks, Sid. So what do you want to do next?
I would go JetBrains next.
Alright.
Unless they already have JetBrains, then they can take something else. I mean, I think that,
You let them choose?
well, yeah, because if they already have the JetBrains, it's not gonna do them any good. And it's a really expensive license. So I would say first, say, do you need to want the JetBrains?
Mohammed?
Mohammed? Is it 2283?
Huh?
Your phone number or something?
Yeah, 783. Yes.
Okay. Alright, so we have JetBrains license, or Pluralsight, or the, what do you want to call this?
The GeoCoin.
The GeoCoin?
I think I'll go with JetBrains.
Alright, come to me afterwards, and I'll get you that number.
Ferrari? No, I didn't bring it this time. Next time. John White?
John Wright?
John Wright?
John?
I actually already have both of those things, so I'm out.
Oh. Do you want the geocode?
Sure.
Alright.
Thank you.
Ian Paulin?
So JetBrains, Pluralsight, or geocode? Alright.
Okay, just come up to me afterwards.
Jim Hill?
Yeah, JetBrains license. How many do we have?
Just 2 this time.
So we're already,
Usually just 1, but we can give away 2.
so we're already done.
What's that?
I already gave away 2.
Oh yeah, okay, then no more JetBrains. Then no more JetBrains.
Yeah, so we're done.
Well, then we can set the
Alright.
coins in the Pluralsight.
But yeah, so Pluralsight or geocode.
GeoCoin, yeah.
Not sure what either of those are, to be fair.
So Pluralsight is a training provider. You can go in here and you
Oh, yeah, let's do that.
Trained in just about anything.
Yeah, no, absolutely.
Technology wise,
Sweet.
You can go there and do that.
Yeah, that's perfect. What about that?
I am?
Nam.
Naam?
So, Pluralsight or geocode? Oh, pretty nice.
Steven? Lives in Naperville. Let's try and narrow it down.
Last name J-A-T?
Yes.
Yep.
There we go.
All right.
Take that point.
The
what? What is this?
It's a geocode.
You ever do geocaching?
Yeah.
So you drive around.
Yeah, it's like a geocaching thing. Like yeah, I can explain it later.
Allison? Yeah. Word.
Alright. So now your only choice. We'll make it easier now.
All right. Yeah, we might do the phone number.
Yeah,
So
let's
we're gonna
do-
do the loyalty system. 312-479-2175 or 3. Can you read
Or
this?
8, no, I think 8175.
2175? I think or 3175?
No, the name, maybe.
Oh, the name?
We're having some handwriting issues.
And
What might redraw, just handwriting, we'll get you something. Brian Coons?
actually, you know what, hold on.
Oh,
For the last one, the last thing we called, does anybody have a ticket, which is the final check, does anybody have a ticket with the number of 2602308?
nope.
Nope.
Here's your winner.
It was you?
No, I'm the
Oh,
next
he's this
guy.
one.
Oh.
Brian? Yep. All right. All right, last one. Howard Loop? Lope? Yep. Thank you, guys.
Is the recording going to be available later?
Well, you can tell them.
You know, so I think the way that it works with this live stream is that it's available via that link for like a month, and then I don't know what happens after this because we've never done it before.
It'll be up there for some period of time?
Yeah, so hopefully it came out, I don't know.
Oh, yeah, that's right.
Oh, nice. Oh, they got so much stuff on there. You want to learn?
I thought I saw an announcement that girl said that.
Yeah, I did. I met him at
Premium version. Oh, it's a prime. Yeah, I don't remind me. It is like,
Yeah, put a link on the meetup site, on the information about the meetup. And I also emailed everybody on the mailing list to let them know the location.
need any help with putting up or anything? Okay.
No.
Just getting it to work, right? I don't know. I got a microphone, I just can't get it. Yeah, I never tried before. I got that microphone there, but I couldn't get it to work. Still.
Maybe the mic on there, right?
Yeah, but it's not as good.
Mindy's live stream was there.
It's a pretty nice system. Yep, see you soon. Thanks for coming.
Oh, yeah, sure.
I'm glad you enjoyed this.
Oh, I really like the track there. Flexibility.
So let's try and go.
Yeah, you can, I can actually, my car, I didn't, my car's in here. But what's your skill set? C-sharp? Yep, we definitely, that's the space I work in. Are you within this area or where do you live? You have any room? Yeah, I'm very so I understand. Yeah, so I work within the downtown, so we handle completely within the, I guess, western suburbs, like Downers Road, this whole coast area, and also in suburbs too. Yeah, absolutely. If it's not, if the area you're looking at might not be the best geographical, you know, check that you're looking so we definitely see a lot. So I need to tell you things. Eventually I want to do education. Let me, here, let me go grab my cards real quick.
I got some really nice pictures.
Thank you much for this.
Oh, you're welcome.
Thanks very much. And nice seeing you again.
Yeah, you too. So the coin, you got a coin, right?
Yeah, I was about to ask you about what to do with this.
There's so there's a, basically, it's, so this website here, it's a geotrackable.org. And you go there and then there's a code here, and it says to activate it, so you enter this code to activate it, you want to activate it, and then you put in, that, so first you put in this code, then you put this code in to activate, and then whatever happens to the coin, you can like enter it into the website like a Where's George kind of thing, and also it glows in the dark, which is kind of neat.
In particular, I find trouble.
Yeah, I like geocaching. So I noticed that like there was a kind of monopoly on trackable items through geocaching. So I decided to have some of my own trackables made. And so I've been working. I haven't worked on the site in a couple of years though.
Because I don't.
But I plan to work on it again. It's got over 1,000 members now. So So, and it's like new likes every day on Facebook, so it's got potential. There's just, you've always got other priorities and stuff.
And I don't
But
know.
people tend to like those points because they're cool and they glow and stuff. And if you don't find them that interesting, I'm sure you can only find if there's somebody in your family that's geocaching or likes coins or whatever. Then you like that. But yeah, very fun items.
Is that recent?
Do you have any?
Is it recent enough to like pick up on some military?
Yeah, we try and do them every month. Are you on the meetup?
Yeah, I am.
On the are you on the software development community meetup?
I am.
Yeah, we try and do them every month. Uncle Bob, he speaks at a bunch of different places. So like, he's done a few at the Schaumburg meetup. So I would join that one too. Night out there. I'll send you a link later.
Yeah.
Hey, just message me so I make sure I email you. Or you got a card or something? I have some cards.
So for me, it's like, well, I think most of the I got. Where do I find the definition of how to get that output? And then you start breaking this apart. And you're going to break it apart with 10 functions to write in the test. And then you basically say, okay, well, this is kind of what I think I would do if I was coding. And now
What the organizer of this meetup?
I help.
The
meetup. You always deliver the speech every meetup.
Okay, make it a dependency. And now
I'm sorry, with the you know, I've heard of several of the speeches. They all tend to be unique. Like I've never seen him do the same one twice. I don't think he does. He always changes them up, and I think that's pretty cool. But
Not easy.
it's awesome because like every time I see his presentation, it's like a little bit different, but aspect of it. And I think I've heard him cover like 3 of the 5 principles now.
All right.
Yeah.
Today is my first time again joining this meetup, so I found like he was talking about open source principles. So what are the things he covers?
Well, the last one started with the S. The S. Separation of concerns, and the interface principles. So we discussed those 2 at the last meetup that I went to that he was at. So I guess that makes sense. So you haven't really discussed this concept of substitution principle or inversion of control.
But I'm more interested in Tedesco principle.
Yeah.
Mind you,
I was reading a book and I was very kind of confused. There was an example between square and rectangle.
Yeah, I know the example you're talking about. You know what? Have you used anything that used like WCF and WPF or SO.L.I.D, where they have the I notify property changes? Have you ever used that?
I notify. Oh, well, I notify.
So you never use like an I notify property change? So like in WPF, or SO.L.I.D, and then when you're doing those, you can add a property called I notify property change, and when you implement that, it'll notify something else of the change made within a property.
Well, I'm not sure I'm following you.
Yeah, but it does not actually affect the input or output from that property. Nothing changes. So this guy's substitution principle indicates that no matter what superclass, the subclasses, the behavior must never change.
Yeah, I understood that.
So like you can add additional functionality or have additional things happen while you're working on properties or functions, but you can't change so that if a different program that implemented that same interface that used that property, nothing should change.
Yeah, so how does it differ between?
Yeah, so
how does it work?
This is a requirement.
Well, that's purely got to do with more like polymorphism and inheritance. And it doesn't really have anything to do with anything.
Well, okay. So when is the next meetup?
The next meetup is going to be.
Thank you guys.
Sure. My acceptance test still fails.
Early May.
So basically we keep that.
Sunday, May 3rd.
Now this one I make pass.
Speak about different.
And it
Robert Martin's not speaking that day. I'm not sure when he's going to speak. It's hard to say.
This is a bigger test. Lots of
Rev 3 is a, Nick, Nick's right there in the back, and she can explain it really well. Basically, it's a startup incubator to help startups get going, help find funding, things like that, steer in the right direction for success. Because DuPage wants startups to be successful and wants them to bring up here.
keep doing this.
So this organization is helping to help make that happen, to help bring new businesses to DuPage.
So really what you're telling me is that it's okay to break the basically the way that I was trying to force to be.
Okay, I'm ready to get the license.
Okay, yep, he is too, so I'm gonna get those right now. Hold on one second.
Before I'm gonna make another test.
No.
And then basically,
Right, you make this pass by writing these.
and it's okay for this to be read where it's not passing. Still,
I'll just email it to you, it's a little bit easier.
Now, once you've gotten it
Okay, password.
you never want it to fail it. So then you have another acceptance test. Which tests some other part of the code, you write a bunch more unit tests.
Okay. Find other colleagues. Actually, right now, I think
Yes.
Oh,
So one of these might test a list with no elements. Doing something with this. So this one might test a list with no elements. This might test a list with one element. This might test a list with 3 elements. So then we're building this up bit by bit.
Yeah, because we want to get.
I'm getting this up and running, so maybe it's refactoring the figure of now take a 4 years of progress. I'm writing like a whole big from here from times. When we write testing from those
Okay, so in the midst of writing all these tests, writing lots of tests, and all these tests call functions in here.
The JetBrains thing is always a little bit of a pain, but what they've done to make it easier now is they actually gave me the codes in advance. That's just super helpful.
In those other classes. So we actually started creating an interesting structure.
And they work for any JetBrains product, I
I
guess?
don't change anything.
So like last week, so they got
How long the license good for?
as far as like you can only upgrade for like a year, but it never expires.
Oh, really?
Yeah.
But if you want the next version, it would be the upgrade.
Yeah, like it upgrades for free for like a year, but after that, then you have to pay to
No
upgrade.
specific test for
But it never like shuts off,
every
which is
line in
cool.
that class is tested by these tests.
I'm still in sharper 7.
Yeah, I get it from work too. It's great to have on there.
For me, it's dependent on every project, so I just went ahead and bought the damn thing for myself.
Yes.
They had like a crazy sale a couple of years ago.
What's the benefit of
They like you could buy the retail.
So that's this at this level. We're
Full
testing
version
at this
of
level,
very sharp.
and we're testing features. And
Less than 50.
if the features are defined,
It's hard out of pocket though. When I mean,
They don't
it's
have
small.
sales. They're like,
It's like a several $100 program. Paying for it out of pocket as a developer is not easy.
right? So it's almost like the same thing.
So that means
I was paying for that independently.
Yeah, I like Pluralsight a lot.
I'm trying to become both.
Oh yeah.
Just on our.
Well, you might be able to. The problem is actually
Yeah, that was a great presentation.
these tests
Should
not be written by
I
programmers.
get some people who email me about
Right. So what's happening is that the programmers are saying, well, I think I'd rather.
Okay, let's see. What's your email?
But they're really writing a unit. Because when programmers write them, they should have done much but they're writing them in this language. So these languages are often called behavior-driven development languages.
That's
They're
right.
usually using a given, when, then kind of format. And these kinds of tests, unit tests, are usually written in code. Now, if you are the author of the test and you're the only one who's going to read the test, what language do you want it written in?
Some of it.
There's a monopoly. It's the same mentality.
Okay, so you've got C#, you've got NUnit, you've got the normal kinds of unit testing. If you are the ones writing the tests, if programmers are the ones writing the tests, all you need is a Write them in code. That's the language you understand. Don't use some other framework, some given when then framework. Especially that's not useful.
Most of the BDDs, you even have to write the.
He's actually from the north side.
Just translated into.
Yeah, you gotta write all
I don't know why
the
this doesn't come in.
Twice as much code now.
It's frustrating.
Now, if you've got business people that are writing this stuff, well, that's really valuable.
I mean, you can write it down if you
Or
want.
if they're not writing it, at least they're reading it, then that's very valuable. Then investing in acceptance tests using a BDD framework is probably.
And it's weird that I can't get my personal
But
email
most-
very easily on this
Most
machine.
programmers aren't in that.
So it's forwarding to my
Most of us
software
don't have
email.
business people that can't do this. So then I would suggest you just do that.
But Microsoft, I saw recently there is a framework called.
I'm gonna try and write that down.
Oh,
Okay.
sure. Can I take a picture of it? Would that be easier?
Sure.
Well, they may
I
think
don't
it's for
remember
programmers, but if it uses this format, it's not.
So.
Because programmers want code. What do you want to see? Do you want to see C#? Do you want to see some new syntax?
I'll have him. Perfect. You know what? I'll have him do that too. If you have any trouble with it, you got my email, you got a card.
This stuff started as customer written tests. But then people started writing tools, those tools bound.
Yeah, I really want to start doing that, like through the International
So then the
Brotherhood of Software
programmers started
Engineers.
writing these tests. And have
Yeah,
practice.
I had some meetings, but like,
And then all of a sudden
like
the programmers
first meeting was
writing this
relatively
stuff,
good, and
and
a
the
lot of people showed
customers
up. But then
aren't
like last people came to the second one,
Why
last
do
people
they
came to
have
the third
customers wanna
one.
do
But more
this?
recently, people have been asking me for do that
much
again.
more
And
I know
really-
you've mentioned it a couple times.
I think we
Yeah,
should.
well,
I
yeah,
definitely.
you're both,
I would like to. I
right?
had a couple people that were interested in mentoring
Yeah.
and like being mentored and stuff.
This is for
And there's one girl that was coming here that was like really smart. And if you want somebody that's like at intern level, so there's definitely the right. I'm sure there's more people like him also that are looking for people that are
testing
to
is neither of
intern.
these two.
That lower it just to get their feet in the door. And then there's talented people that want to get there. And I think finding ways to get
It's
all that
usually
together.
written in.
I think that'd be great.
Group C.
Taking like a little time to get back to
If
community
the
and doing
tests
some
are
like classes and stuff.
So
I
if
really
they're,
want to do that.
Yeah,
If they're
I've never
plumbing
done it
tests,
before, but I mean.
putting
it
2 or
seems
3
like a
components
good
together and
idea.
making sure that those components.
Well, I think it's like he said, it's like herding cats.
Like the file.
If they're business rules,
Yeah.
But
that the
I mean, we
business
could
is
ask him about it.
interested
He
in,
might
then they're
have some
probably-
input.
Yeah.
It all depends on the audience. If the business needs to see it, you want to write it in that.
I didn't even
style.
think of this. This should work.
If the technical people need to see it,
Excuse me. What's your phone number to your cell phone?
Do you recommend any
Four,
any any book for you. So there's several books.
3, 6, 2, 7, 8,
So there's
3.
TDD by Kent Beck.
Okay.
Very good. It's very primitive, but it's very good. There's also TDD by David Stells.
See if I walk over by the window. Hold on.
Oh, never saw it.
And that one is also very good. If I would read the Kent Beck book first. All right. Thank you. And then there's an awful lot of documentation on the internet. Blogs and articles and things that people have written on here.
Yeah, you feel lost.
Oh, you know, grab me one. Stephanie,
So,
grab me one.
go to my blog.
Promise my girlfriend I would bring her a pizza.
And you can buy a book too.
Yeah.
What's your second choice?
Thank you.
Cheese or
Yeah,
veggie?
you're welcome.
See, when it comes to the TDD, it is easy in principle, but if you're trying to put it all together and make it flow smoothly, that is where I think basically it gets tough really quickly. And then you have to refactor the, I mean, for me, it's like I kind of begin to kind of get into the idea that, when you write the test, some of them you refactor.
There you go.
You also refactor.
Can you take a photo of that?
Excuse me. Use
Because I'm having trouble
dependency
sending it.
injection, and some of it is basically permanent, and that's for unit testing, excuse me, for the requirements, and for unit testing, you basically do abstraction. So, and that kind of nicely flows. And I think that's. I was hoping that you can actually give some clues when it comes to
So it's not just me that
mechanics of actually writing those tests. And I know that this is not exactly about the subject of implementation today. But to me, it kind of looks like there are some rules that you can kind of follow, and it looks like you can calculate
That is true.
it's like, just understanding the definitions, and you have to be super.
You don't have.
I think it's sent.
You have to memorize.
Well, you have my email. If you don't get it, let me know.
It's like, you're gonna.
Yeah, it's a really good price. It's like
With the patterns, you have to
it's like
record-
up to like a $700 value.
Sure. Yeah. I mean, boost. It's like, no, I saw the patterns and say, okay, well, exactly, what do you mean? What is the definition of the command?
Both cheese.
I mean, like, how do I recognize it?
This one, they both have like a
Yeah.
Simple example. But then
I'm a software
one method, so
I'll grab this one and
I said, well, but
Oh, really?
you want to return something from that method. Will that make sense? If so, what? And actually, I'm trying to come up with
more?
I can introduce.
Well, when I started my career, I wasn't
So, no,
I was
it is
more
not
into
part of what
web.
they-
Now it's a kind of
is
server
operating
side.
That cannot be
Like in the
extracted from that information, and if that is the case, you can return it. If it is not the case, it will bite you down the road.
The system.
So this is kind of a, I'm beginning to recognize those kind of patterns.
If you want to make a framework,
Yeah, they give you the basics, but they will not tell you exactly what are the specific rules to not to get burned down the road. That's what I was kind
rest of the
of
process.
saying.
You can bind themselves and you can set that boundary.
Probably should return something from that.
Well,
Unless
you
it's something
can.
completely orthogonal. Yeah, if it's in the. You're right, you don't get a lot of that guidance from books and
Where
articles.
from?
Nowhere. I mean, I didn't find any of that stuff.
You can get some of that by reading the code.
That's true.
This is so time consuming.
No, I'm not.
Life is hard.
Well, you are older than I am. Okay, fine. But you should value your time even more so. Okay, it just goes with things like there is no tomorrow. So, to me, it's like, okay, well, there's something either way, obviously. I mean, we try to plagiarize each other as much as possible, right? So,
Thank you.
what would you expect? I'm asking, what is the easy way?
There's no easy way.
Yeah.
One last question.
I'm gonna upload some more photos and then I'm going to
Let's say when you start reading the physical people can just, I see one class and then I think it's okay. I want like four different classes, second day. And like you said, like, when should I know, okay?
Yeah, well, how did I send them to you last time? I don't remember.
Follow these guys.
I think I downloaded them from Meetup.
Were you able to do that? Did you have to do them one at a time?
I did.
Because I.
Okay, so if you could give me a flash drive, I can use the flash drive.
And again, I feel like,
So the rule for interface segregation is
what happened in
different parts of the company
not because I don't appreciate
that
it.
are going to ask you for changes.
So I want to get
isolate.
I want to get.
You want to isolate the code that's going to change based on those
The
different
category company, right? That's what I'm trying.
So if you're writing a system and you've got some accountants over here, and they're going to make one kind of change to their products, right? So which may be and you've got some people out here who are data entry. And they're going to ask you to make other kinds of changes, probably at network. And you got some other people out here, and they're and they're going to ask you to make changes on the reports and the logs.
Do that, and then we'll find other places to call in and use this value.
If these guys are going to be asking for a lot of changes, then you'd like to divide the system into those three parts.
You wanna go to talk?
So that you separated the responsibilities.
Good.
Okay, nice to see you.
Yeah,
What's
see
your
you
name?
later. Mike. Good meeting you. Here, let me get your card.
I
This
got
is
it,
the
got it.
interface.
Oh, I did get you one? Okay, cool.
I'm going to want.
Okay, see you guys later.
See you. See you guys.
This is the single responsibility. You were asking me about interface. So I completely screwed up.
But it was all catch to
Interface segregation principle, I've got a bunch of users.
And yeah, on the other part, it says, okay, I don't mind benefits of the person.
All these users are using some class.
But the real is
There's a bunch of methods in this. If I make a change to one of these methods, all of these guys have to be recompiled. Even if they don't call the method to change. Right? Okay. And so then the goal is to bring out interfaces.
Exactly.
You still gotta test it.
And then you have to actually play it back and say, well, you can actually divide.
If you have 20 tests on your method,
So off the show, yeah, that's 350 grand, but then off the show, it's all
These are inheritance relationships. Those are using relationships. These interfaces contain only the methods that these users want.
I mean, frankly, the only way you can refactor your code.
This class doesn't contain all the methods.
And you'll never do that.
And now if one of these changes, you'll have to change it here. That guy will have to recall. But you don't have to change it here because it doesn't exist there. It doesn't exist there, so these guys don't get
Change my statement to refactor.
Now you're asking me, when do you do this? You do this when you start feeling the problem of compiling too much. You make a change here and you say that recompile. There was no reason for it to recompile. There was no reason why I have to redeploy this. Maybe there's some whole massive network of classes out here. And they all have to recompile. They all have to recompile. Wow. I don't want them deployed, that's when it's this kind of separation. Now, there's a bunch of reasons why you don't want something to recompile. So one of them is maybe this belongs in its own jar file. And you'd rather not redeploy that jar file just because something changed it. So that would be one case. Break out an interface to protect that jar file from being redeployed. Another case, there's one team working on this bit of the software, there's another team working on that bit of the software.
When you ask a question,
And I don't want a change made on this side that affects like that.
But it actually,
So I can put those interfaces in and protect those two teams.
no, kind of put some burden on.
Will it help you?
Okay, well, how do you eliminate that? How do you eliminate that? How do you see through the what should I
just looking at that, I
and these codes should have a level of test and start kind of saying, how do I actually approach it in
at what point is okay?
So there is
Do I wait for some client to pop up? I'm using it.
I will wait for the clients. Yeah.
Okay, that's one.
The clients will tell you how to group these interfaces. What language are you using?
That's what I'm saying.
Any static type language.
Where did you find this?
Yeah, the type language.
Just the whole that I had in my briefcase.
128 megabytes.
Oh, seriously?
What do I string? I need to come up with
That won't be anything.
All right, I'm out of here.
very complex rules.
Okay.
The rules are,
Thank you very much.
Thanks for coming, that was a
Bye-bye.
great presentation.
Thank you very much.
See you later.
and the rules are kind of involved, and they intentionally, it's a basically a school project.
You bet.
Well, project, it's just like a school like that.
I'll grab them from me.
So you intentionally pick some.
Sir,
almost-
no, you don't have an extra flash drive, do you?
Pick on the rules, for instance.
If you want,
And,
I could give you the flash drive, or the SD card, if you got a computer, they'll take it.
Intentionally.
No, right now.
Okay,
It's
yeah.
all right.
Well, when you pick them from Meetup, though, you get to cherry pick the best ones anyway. When I give them to you on a disc, you get all the terrible ones.
No, that's perfect.
So what'd you think?
Like a problem like mine.
That's actually a very good way to describe it.
Okay, and we are cutting off the stream.
I think it is much better.